So when it comes to PERT model, right? So PERT model is based on probability. It is not a deterministic model what we studied in CPM, critical path method. So in PERT model, whenever we are working on, although we'll calculate the critical path like the way we used to calculate in the critical path method also by using forward pass calculation, backward pass calculation, but here the time interval for completing each project within the activities whatever is given, they in the problem they will be giving us three time. One time they will call that is called optimistic time. One time we'll call this is a optimistic time. The another time we'll call that as a most likely time, most likely possible time, most likely time. Okay, and the third time will be pessimistic time. I hope by the word itself you can understand the meaning of this time period. So like for each activity, because you know that whenever we talk about project management is all about working on different interrelated activities based on certain objective, where your objective should be very clear, and in based upon that objective we are trying to work on a project. So whenever we are working on a project, whenever we are doing the planned set of assignments which we are doing all together, a project is made of activities and each activities takes certain time for them to get over. So when we are doing critical path method, we assume the time period for each activity and we believe as if the assumption whatever we made will hold true, but in reality it may or may not happen like that way. Optimistic time period means, imagine if things happen the way we expected and much more better than, so optimistically like probably then it would be definitely will you'll end up in completing the work in much more lesser time. Most likely time is generally how much time the work is going to take to complete, and pessimistic time is worst case scenario. Imagine if you get scarcity of resources, or you got some problem with vendor or something like that, some kind of issues, conflict, or unrelated scenarios developed, which ultimately delayed the activities when you are doing on. So with this, you can say the pessimistic time would be more than your most likely time, and then this would be more than your optimistic time. So what we do in the PERT in CPM and PERT model. So here, first thing what we do, we first find the expected time for doing the work. So the expected time for doing the work that will calculate by the formula called optimistic time plus 4 times of most likely time plus pessimistic time divided by 6. So this will give us the expected time for completing each activity. So for each activity, what we'll do, we'll calculate this expected time. And then what we can do, we'll find the variance for each activity. Variance is a square of standard deviation, right? So we'll calculate the variance of each activity. So variance of each activity will calculate the formula of variance is pessimistic time minus optimistic time divided by 6 whole square. This will give us the variance of each activity. Okay, so once we do this calculation, so then for each time, like suppose if this is your problem, so here different activities are given and they have given us optimistic time, most likely time, pessimistic time. Okay, so optimistic time I'm representing with T0, most likely time with TM, pessimistic time with TP. So I'll just follow a formula of finding the expected time. So I'll just write here expected time. So for each activity to get over, what is your expected time? So the formula what I need to follow for expected time is your optimistic time plus four times of four times of most likely time. Okay, plus your pessimistic time. Okay, this I'll divide by the 6. So this will give you the expected time for each activity. Clear everyone? This will give you the expected time for each activity. It is very simple. Okay, it is very simple when if you are trying to work on this. Okay, I'll just show you this. So like how to find the expected time for suppose for activity A. what you need to do, you need to follow the formula optimistic time plus 4 times of most likely time plus pessimistic time divided by 6. This will be your expected time. Optimistic time for activity is 3 plus 4 into 6 plus 9 divided by 6. 6 4s are 24, 24 plus 12 is 24 plus 12 is 36. 36 by 6 will be 6. Simple. Can you understand this? Any doubt? Shane, any doubt? Any doubt, Sangeeta, Yashashwini, any doubt? Clear, no, guys? You're getting it. Like for activity B, if I want to calculate, for activity B, so for that, the optimistic time is 2 plus 4 times of optimistic time is 2 plus 4 times of most likely time, that is 5. So 2 plus 4 into 5 plus 8 divided by 6. 4 5s are 20, 20 plus 10, 30, 30 by 6, 5. Can you understand this? Anyone have any doubt? Any doubt, anyone? Clear now, everyone? So you can find the expected time for each activity. Find gradually what you can do. Gradually what you can do. You can find the variance for each activity. You can find the variance for each activity. So what is the formula of variance? The formula of variance, the formula of variance is your pessimistic time minus your optimistic time. Okay, divide by 6. Okay, this what is the value you get? You do the square of this one. This will give you the variance. Clear? Anyone, any doubt?
No, Amit, it's clear.
Everyone, no, clear? So we just need to find the variance of the, what is the variance of first? This is 9 minus 3, 6. 6 divided by 6, 1. 1 square, 1. 8 minus 2, 6. 6 by 6, 1. 1 square. Then this is 6 minus 2, 4. 4 by 6, 2 by 3. 2 by 3 square. 2 by 3 square is what? 4 by 9. So this is 4 by 9. You can write this as 4 by 9. This you can write 4 by 9. This is 6 minus 2, like you did now. 10 minus 2, 8. 8 by 6, 4 by 3. 4 by 3 square, 16 by 9. This is 16 by 9. So like this, you can find the variance for each activity. You know the formula. What is the formula of expected time? What is the formula of variance? You just use that formula, you'll get the answer. Then everyone. So you find the expected time for each activity. Find the expected time for each activity. Find the variance for each activity. I hope this much part is clear with all of you. So once you find the expected time and variance of each activity, what we do, we draw the network diagram. Okay, we'll draw the network diagram. So you can see this. So what are the activities are given to you. Now what matters here is the activity. Okay, what matters is your predecessor. What are your predecessor? And what matters is your expected time and the variance. What matters is now your expected time and your variance. Okay, so you just write down, if I write down the same question here. Okay, if I write down the Same question here. So activity are A, B, C, D, E, F, G. So A, B, C, D, E, F, G. Okay, so predecessor for this is none. A and B, they don't have any predecessor. Okay, for this is A, for this is B, then this is B, then this is C comma D, and this is E. Expected time for A, whatever you calculate, you just write it down from here. A 654 654 65444 65444 expected time, and then double six double six. Then variance is double one, then 4/9. Okay, then it was this is 16/9, right? 16/9, correct? Then it was yeah, 8 by 6 means 4/3, 16/9. Then this was 16/9. Then it was, then this is 10 by 6, 5/3, 5/3 square means 25/9, 25/9, 25/9. Then it was, this is again 4/9, right? It is again 4/9, 4/6, 2/3, 4/9. Yeah. Then this is what, 15 minus 1, 14, 14/6. 14/6 means 7/3. 7/3 means 49/9. 49/9. 49/9. So you got the variance of each activity, you got the expected time, everything. Now what you do, based on this data, no, based on this data, draw the network diagram. Very simple.
So once again, you explain that variance, sir.
Variance, this is the formula, Sangeeta. Variance, this is the formula for variance. Pessimistic time minus optimistic time divide by 6 whole square. So,
Two. Okay.
so here, like if you see first one, if I see the first one, maybe this first one, 9. 9 minus 3. 9 pessimistic minus optimistic. 9 minus 3 is 6.
So okay. 9 minus 3 divided by 6.
6
In
whole square.
okay.
Square of them. 8 minus
9
2.
minus 3.
3 is 6. 6/6 is 1. 1 square is 1.
Minus 3. Okay, sir.
Then second one, 8 minus 2, 6. 6/6, 1. 1 square, 1.
1 square. Okay.
Third one, 6 minus 2, 4.
Okay. 6 minus
4. 4/6, 2/3. 2/3 square, 4/9.
Okay, sir. Now I got it.
So once you get this value, once you got this value, so once you got this value, now we need to draw the network diagram. We
So
know,
then how you wrote that 4/9?
so
16
same
by
thing.
9.
So either you write in decimal or you can write in fraction, na?
Okay.
444. So you can write either in decimal or you can write in fraction.
Okay. We can write in both also, no, sir?
Both the way, whatever, it depends gradually. No, once you move further, you'll understand. Gradually
Okay, sir.
see what is best way. So,
Okay.
so here now we need to draw the network diagram. You know how to draw the network diagram. A and B, they don't have any predecessor. This is A. So this is 2. You know how to draw the network diagram. This is B. Suppose this is 3. A and B don't have any predecessor. From A you have C. From B you have D and E. From A you have C, and from B you have D and E. So C and D will make F. C and D you will get F. So A and B don't have predecessor. From A, B, from B you have D. From B you have E also. Okay, so E you have G. From E you have G. From E you have G, and F is nothing. No? After F you don't have anything. No? From E you have G. So there you can extend F, and this from E you have G. So you can end it. You just need to draw the network. You got this right?
So 1 second, you repeat, sir. I'm getting confused.
So diagram, So what we'll do, we'll start from 1. See this
Okay.
A and B, they don't need it.
It's variance, no, sir?
No, this first we'll draw the network diagram.
Okay, okay.
You want variance?
No, sir, which one you are drawing?
I'm drawing network diagram.
That one I got to know, sir.
Huh.
But you one. Okay.
Network diagram is clear, na? So you have A, then you have this.
Yeah. Okay, 2.
You have B.
3.
Always we draw from left to right.
Okay, sir.
You know that. Then A and B don't have any predecessor. From A you have C.
Okay, it's none also. That's why we wrote like this.
Yeah. So So from from A you have C. From B you have D. So in C and D, from A you have C,
D.
you have D.
Yeah, okay.
From C and D you have F. You have F.
F.
B you have G.
G E.
From G, okay. From B you have E, then G.
G E.
Yeah. From B you have E. From B you have E. From E you have G.
E.
So from B you have E, and from E you have G.
G. Okay. Now I got to know.
So here we'll put the numbering. Numbering would be expected time. Like for A, this is 6. The numbering is 6. For B, it is 5. Expected time to do. C is 4. For D is 4. It is 4. For D, it is 4. For E, it is 4. For E, it is 4. And then for F6, G6. For F6, G6. So now once you know this, now we draw this forward pass calculation, which we have forward pass, backward pass calculation. Now once we're done with this, we'll do forward pass, backward pass calculation. You remember, no? We have done it. So we'll start.
Yes, sir, remember.
Write 0. 0 plus 6. Here will be 6. Then 6 plus 4, this will be 10. 0 plus 5, this will be 5. 5 plus 4, 9. Which is bigger number? 9 or 10? 10. 10 plus 6, it would be 16. 5 plus 4, 9. 9 plus 6, 15. 10 plus 6, 16. So which is a bigger number? 16. Guys, any doubt? Vani, Shane, any doubt?
No, sir, no doubt.
Vani, Shane, any doubt?
No, sir.
Okay. Shane, any doubt? Shane is not there. So this is called forward pass calculation. Then we'll do backward pass calculation. You start from 16. 16 minus 6, 10.
10.
Minus 6.
10. 4.
Then 16 minus 6, you'll get 10. Then 10 minus 4, 6.
6.
10 minus 4, here you'll get 6. So here 6 only. 6 minus 5, you'll get 1. Then 10 minus 4, you'll get 6. And from 6 minus 6, you'll get 0.
0.
It's called backward pass calculation.
Okay.
So that path you will consider as a critical path where your numerator and denominator both are same. If you observe your numerator, denominator, if both are same, if they are same, so you just connect them. You call that as a critical path. This, this, this is called critical path. So this is called the in CPM also critical path method also. We were doing the same thing. Only thing there, the network diagram and one will be little bit difficult. And but we use the same forward pass, backward pass calculation. Everything we did the same way, nothing different with. And then we used to calculate float, independent float. We used to get free float. So we used to calculate float there. So here we'll not talk about float or head event slack, tail event slack, all that thing. Here you just need to aware about what is the critical path. So if you write your critical path is your critical path is 1, 2, 4, 6. That is your critical path. And your expected time to complete the project. Expected time to complete the project is, see in the question they will give you data, 16 days, 16 weeks, 16 months, something would be given in the question. Here what is given, if I read the question, they have not given as such. Maybe they're given week. Yeah, they mentioned no. Find the probability of completing the project in 18 weeks. So this is in week. The expected time is in week. This data you can see. 18 week. So that means the time it is given in week. So your expected time is week. Now variance of critical path, variance. So now the calculation of variance will come into picture. So your critical path is 1 to 2, then 2 to 4, and then 4 to 6. 1 to 2 variance is 1 to 2 variance is 1. 1 to 2 means A, right? 1 to 2 means A, right? What is 2 to 4? 2 to 4 means C, right? 2 to 4 is C. What is 4 to 6? F. ACF, see the variance of ACF. A is 1, C is 4 by 9, F is 4 by 9. 1 plus 4 by 9 plus 4 by 9. 1 plus 4 by 9 plus 4 by 9. You get 1 plus 8 by 9. 17 by 9. This will be your variance. Clear? Otherwise, you people use calculator. You people love to use calculator, so you can use 8 by 9 will be 1. This would be 1.888888. 8 by 9. Correct me if I'm wrong. Correct, guys? Any doubt? Any doubt? This is your variance. Your standard deviation will be what? Square root of this. 1.374. This will be your standard deviation. This will be your variance. Variance of critical path. This will be your standard deviation. Any doubt, guys? This is your variance. Clear?
No, sir.
What is your standard deviation? I hope you know what is standard deviation. You studied in first semester, which result is coming very soon. So your standard deviation is under root of 1.8888 infinite time. That is 1.34 something, 1.374 something, 36 something. Okay, so once you've done this, you draw, because you have to calculate probability, right? Draw the network diagram. So under the network diagram, your variance, your uh, expected time to complete the project was, what is the expected time to 16 weeks? Okay, this is expected time to complete the project, where the standard deviation was 1.374 weeks something. Can you understand this? They are what they are asking you. They are asking you calculate the probability that the project will get over in 18 weeks. You understand? They are asking you this. Calculate the probability that the project will get over in 18 weeks. Means they are asking you this area. This area under the normal distribution. Asking you this area under the normal distribution. Can you understand this? All this you did in first semester in exam. Don't tell me that you forgot all this. 18 lies right hand side of 16, right? Clear? Any doubt, anyone? Any doubt, anyone? Any doubt?
No, sir.
No, no.
Yes, sir.
So here, guys, if you remember, if this is a normal distribution curve, in normal distribution curve, 50% of area will lie left hand side, 50% area will lie on right hand side. Okay, so if you remember standard normal distribution curve, so if I see this, if I write this A, if I write this A, B, C, D, I need to find this area. No? So the probability probability that the project get over probability that the project get over by 18 weeks means I need to find the area of this curve ABCD. Can you understand this? So this area of this curve ABCD is nothing but it is the area of the curve EFCD plus area of the curve ABEF. Can you understand this? Already you have done all this in first semester. So please don't think that you don't know all this. Clear? So you know that area of the curve EFCD will be 0.5. Normal distribution curve 50% left hand side, 50% right hand side, correct? And then area of the curve ABEF you will calculate by the formula x bar minus mu by sigma. This is a formula, no? Normal distribution. X bar is 18, mu is 16 week, which is expected time. X bar is sample data, sample mean. This is population mean divided by standard deviation. That is 1.374, which is 2 by 1.374. So this area you want 2 divided by 1.374. So if I ask you to divide by this area, it means you have to find 1.455. 1.455. This area you want. Can you understand this? This area you want. This is the formula. In exam, your main exam, you get numerical also based on normal distribution. You did also. Whenever you talk about normal distribution curve, 50% of your area will lie left hand side. 50% of area will lie right hand side. This area, you know, this is 0.5. I want this area. I want this area. So getting this area, this is the formula. This I have taught you in class. Yes or no?
Yes.
So your actual area is your actual area is 0.5 plus this area. So this area, now how will you get this value? So now what you'll do, we'll look into we'll look into we'll look into standard normal distribution curve. We'll look into standard normal distribution curve. We'll look into standard normal distribution curve to find z area corresponding to. Will find standard normal distribution curve to find the area corresponding to z value 1.45. Now everyone open normal distribution curve fast. Google it about normal distribution table. Google about normal distribution table. Now this, in this normal distribution table, I want the value called 1.455. So you can just go vertically, go till 1.4, and then if you observe, you have 1.40, then 41, like that. So this is 1.40. You can see this is 1.40. This is 1.40. Okay, this is 1.41. This is 1.41. This is 1.42. This is 1.43. Okay, this is 1.44. This is 1.45. Can you understand this? 1.45. Yes or no, guys? 0.4265. So the value corresponding this is 0.4265. So the probability, this probability that your work get over, so the probability that your work will get over by 18 weeks, that will be 92.65%. This is your answer. Can you understand this? Take some time, think about this. See this, take some time, think about this. Guys, did you understand this?
Yes, sir.
So this is like how this we do the problems on the PERT model. So it's generally the application of critical path method only. Only thing in the case of critical method, we are were given
So
one.
one second. So you show that I'm writing.
And so they used to show.
This.
So here in the case of critical path method, we believe it's a deterministic model, but in the case of PERT model, we believe it's a model based on probability, where there's always an uncertainty is there. That's why we use normal distribution curve. So under the standard normal distribution curve, we used to calculate the probability that your project will get over defined on the time interval, whatever is